of a formula, you only have one, okay? So go ahead and in your notes, jot down your formula here. All right, so basically what you're going to do is take your probabilities separately and you're going to multiply them together. Okay, so one thing that I want you to jot down in your notes somewhere around this is that we want to think about keywords as we kind of start this section. So I want you to start thinking that if you have the word "and" in a problem, that should be telling you to multiply. And then if you have the word "or," like we saw in the last section, that is indicating that there should be some addition. Okay, and so that'll help a little bit as we start mixing these problems up. If you can remember, hey, when it's an "and," I'm supposed to multiply. When it's an "or," I'm supposed to add. Okay, so all we're going to do today is we're going to do just as many examples as we can squeeze in so that you get the most number of problems to kind of work from. They're all going to use this formula with the multiplication in between. All right, so I'm going to go ahead and go to our first example. All right, so I'm not sure how you want to handle this. I don't know that in terms of the whole class period, you're going to want to write down every single problem. You might grab your phone and take pictures of them and leave a space in your notes, and you could always go back and write later. Or if you can write quickly, we'll take a minute or two on each one, but we want to get through the problems more importantly than spending so much time writing them down. So you may need to take some pictures as we go. All right, so this one says a coin is flipped and a die is rolled. Find the probability of getting a head on the coin and a 4 on the die. Okay, so what I would suggest that as you read through this problem, first of all, that you pick up on the "and" in the question. All right, it says find the probability of getting a head on the coin and a 4 on the die. So kind of key in on the "and" so that we know that it's going to be an "and" problem. And then we're going to look to the left, and that's going to give me one of the events. And then we're going to look to the right, and that should give me the other one. So to the left, we want getting ahead. So I'm going to go ahead and just kind of write this down here. So head on the coin. And then the second part is getting a 4 on the die. All right, so I know that my formula says that I'm going to do these things separately and put a multiplication in between. All right, so once that's done, then we need to figure out those two probabilities. So when you flip a coin, somebody tell me what the probability of flipping heads would be when you flip a coin. You can put it in chat if you want, if you know it, if you don't want to say it. Good. Good, Madison. 1 out of 2. All right, because we know that the sample space for the coin for one flip looks like heads or tails. And so the probability of getting heads, there's one head in the sample space out of 2 things altogether. Okay, now what about on a die? Right, so rolling a 4. What is your probability for rolling a 4 on the die? Good, 1 out of 6. All right, and again, you think about your sample space for the die. It has all these numbers 1 through 6, and we're only interested in the 4, so that's one option out of 6. Okay, and then we multiply to get our answer. So when you're multiplying fractions, you multiply the top 2 numbers together. So 1 times 1, and you multiply the bottom 2 numbers together. So 2 times 6 is 12. All right, so that's that one. Does anybody have a question there? It's kind of, that one hopefully seems kind of easy. That's just kind of getting us a feel for how that formula works. Does anybody need to ask a question on that one?
I have a question.
Sure.
Okay, so when it say the probability with parentheses over the 4 and y'all had put 1/6, how did y'all get that? Because I would have put like, I don't know, 4/6 because the 4.
Okay. Yeah, so that's common, India, to put the 4 on the top. But you want to remember that you're counting in both cases. So when you look at your sample space up here and they're asking for 4s, the question is how many 4s are there in the sample space? And there's just one, right? So the 1 goes on the top, and then the bottom number is how many things are in the sample space, and that's where you're counting everything.
Okay. Thank you.
Mm-hmm. All right, anybody else? Question on that one? Okay, so let's move on and try another one. All right, so we know we have lots of card problems, and you've got your card picture on your phone, hopefully. It says a card is drawn from a deck and replaced. A second card is drawn. Find the probability of getting a queen. All right, and then here's my and then an ace. All right, so again, you find that and kind of as your keyword. You're going to look usually to the left to get one of the events and to the right to get the other one. All right, so I'm going to kind of jot this down and set it up. So we want the probability of getting a queen. That's the first thing. And an ace. That's the second thing. And remember again, your formula just says split them up and put a multiplication in between. All right, so we know that when we're doing a deck of cards, the sample space is 52 possible outcomes. And this is one of those where we don't list it out because it's too long, but you have your picture. All right, so if it's 52 possible outcomes, I know that both of these fractions have a 52 on the bottom. That's the total number of different things. All right, so what goes on top for the queen probability? So I'm asking myself basically how many queens are there in the deck?
4.
4. Good, Victor, thank you. All right, and then for the aces, you're saying to yourself how many aces are in the deck?
4.
4. Okay, So now the only thing, and I should have said this in the beginning, that I want to kind of point out to you as we do this is note that, look at this first sentence for just a second. We haven't done anything wrong, but I just want you to look at this. Okay, so it says a card is drawn from the deck and it's replaced. So that the fact that it says it's replaced is a really important thing that you need to pay attention to. So that means that when you pick that queen out of the deck, that you looked at it and you said, oh, I've got a queen, which is what I wanted. And then you're going to put the card back in the deck, right, before you draw the second card. So sometimes you'll see that you replace the cards. And as we look in other problems, sometimes it might say we don't replace it. And we'll talk about that when we get there. But you want to pay attention as you're doing these two events to whether you're putting the first thing back or you're holding it out. All right, so just kind of keep that in mind. Like I said, we'll get to one in just a minute that's not replaced. All right, so let's go ahead and multiply these two things together. So 4 times 4 is going to be 16. All right, and then 52 times 52, I'm doing that on my calculator, is 2704. And I need to reduce that, and this is really where using your calculator to reduce a fraction is going to be much more helpful than trying to do it by yourself. So I talked with some of you on Monday in the homework session about how to do this on your calculator. If you still are having trouble with that or you don't know how to do that, you need to touch base with me at some point because we want to be able to reduce these things quickly. We don't want to get hung up on having to reduce things by hand. So this thing is going to reduce to 1 over 169. Okay. All right, anybody have a question on that one? All right, so we'll move on to something else then. Okay, so on this one, it says that we have this box that contains 3 red balls, 2 blue balls, and 5 white balls. Okay, so you can kind of picture that box in your head, 3 red, 2 blue, 5 white inside the box. A ball is selected, its color noted, and then it is replaced. Okay, so again, that's important for me to sort of make a note of. I'm going to put that first ball back in the box before I pick the second one. A second ball is selected and its color is noted. Find the probability of, and we've got a couple of different things that we want to work on here. All right, so the first one says that we want to find the probability of selecting 2 white balls. All right, so this sometimes can be difficult for students because we are conditioned to look for the and there's not really an and in this problem in the first part where it says selecting 2 white balls. It doesn't say an and so you kind of have to read it into the problem. You have to say to yourself, okay, well that it really does mean and because I could have seen it written as selecting 1 white ball and then a second white ball. Okay, so we've got this sequence of events, and so when I write it down to work it out, I'm going to write it down with the and in between. So I'm going to say white on the first draw. Okay, so I want the first one to be white, and I want the second one to be white. All right, so I wanted you to see that because it doesn't start off with the and, but it is an and problem. Okay, so first ball is white and the second one is white. That means the same thing as selecting 2 white balls. All right, so let me apply my formula. My formula says that I'm going to break it up and put the multiplication in between. All right, so the first time I reach into the box, what are my chances of pulling out a white ball?
Would it be 5/12?
It would be, yeah, over, I think 10 though, right? Because you have 3 red.
Yeah, you're right. My fault.
Yeah, but yes. Okay, so 5 on the top because there are 5 white balls in the box, and 10 on the bottom because there's 10 balls altogether, right? So you had 3 red, you had 2 blue, you had 5 white. Add those together, we get 10. Okay, and then you picked your white ball, so you're kind of holding it, and note that the problem says you're going to replace it. So you're going to put it back in the box before you reach in for the second ball. All right, so when you reach in for the second ball, there are still 5 white balls in there and 10 altogether. All right, so I'm going to multiply. 5 times 5 is 25. 10 times 10 is 100. I'm going to reduce that on my calculator. It'll reduce to 1/4. All right, anybody have a question on that part? Okay, so you guys go ahead and do part 2 for me. I'm gonna give you just a minute. Do the probability of picking a blue ball first and then a white ball. All right, so what did you put down for the probability of picking a blue one out the first time?
It'd be 2/10.
Good, yeah, 2/10. Everybody agree with that? There are 2 blue ones in the box. There are 10 altogether. All right, and then we already did the white one. We know that that's 5/10 for a white one. All right, so 2 times 5 is 10 on the top. 10 times 10 is 100 on the bottom. And that will reduce to 1/10. All right, so any questions on that one? Okay, so this last one is a little bit harder, and I wanted you to see it because you are going to have some similar problems like this in your homework. You'll have some where they're talking about like a situation like this, 2 balls of the same color. They could do 2 cards of the same suit. All right, so you're going to see some of these where you've got some different scenarios going on, and I wanted you to see how to work this. So we kind of have to think about what this is actually saying. 2 balls of the same color. So that means that one option, one way that I could do that would be that I could select 2 white balls. All right. Or another way that I could do this would be that I could select 2 red balls. or I could select 2 blue balls. So if it says same color, you need to think about each of the different possibilities separately. Same color could mean that I get both white, both red, or both blue. All right, so for the 2 white, we did that up here, right? That was the part A. So I already know that the answer to selecting 2 white is 1/4. Okay, now remember we said right at the beginning of class, I said that I wanted you to watch for the word or and the word and that and would tell you to multiply, and that or would tell you to add. So I'm going to go ahead and put like a plus sign right underneath that or, because I know that if it's this option or this option, I'm going to add together. All right, everybody okay so far? All right, so I want to ask you a question about this first part where we worked out the 2 white balls. So if instead of having said 2 white balls, I had said 2 red balls, then the problem works pretty much the same way, correct? Like we would have said red and red. We would have broken up the probabilities. Now our numbers are going to change a little bit. What would the probability of picking a red ball out of this box be?
2/10.
3/10, right? We have
Oh, yeah.
3 red, yeah? Okay, so we would have a 3 right here and a 3 right here. So I'm just kind of fixing that as I go. All right, and so our answer would be 3 times 3 is going to be 9, and 10 times 10 would be 100. All right, so everybody okay with that? 9/100 for the 2 reds. All right, so let's look at it then for the blues. All right, so 2 blues would be blue and blue. Right, what's the probability of selecting blue the first time you pick one? That would be the 2/10, right? Because there are 2 blue ones. All right, so that answer would be 2 times 2 is 4.
4/.
Right, 4/100. Okay.
Do you reduce that or keep it like that?
It depends on how you're going to work it out. Like if you're going to just put it in your calculator, it doesn't really matter. So I think that's what I'm going to do. It is definitely easier if you're not using your calculator to have it have a common denominator. But I'm just going to type it in my calculator, the whole thing. And I don't have to use any parentheses or anything. It should just type in exactly like I've got. I'm going to type in 1 divided by 4 plus 9 divided by 100 plus 4 divided by 100. All right, and I get 0.38, which if I take it back to fraction form on my calculator, it's 19/50. And it just depends on what Connect Math is asking for. If they want a fraction or a decimal, you can give it either way. Okay. All right. Anybody have a question on that? Okay. All right, so let's go ahead. We'll move on to the next problem. All right, this is also a very common setup in the homework. So you'll see a fair number of these kinds of problems where they're giving you a percentage and then they're asking you to find a probability that multiple people are doing something. So this says a poll finds that 46% of Americans say they suffer great stress at least once a week. If 3 people are selected at random, find the probability that, and the first part says all 3 will say that they suffer great stress at least once a week. Okay, I can tell you that in a problem, if you see the word all, that this always means that it should be an and problem. But the issue with this is kind of like in the first ball problem, we don't actually have the ands. So I kind of have to write it so that the ands are there so that I know how to do it, so that I know how to work the problem. So if it says all 3 people say they suffer great stress, I'm going to write something to the effect of, I don't want to write too much here. I'm going to write that the first person says that they're stressed and the second person says that they're stressed and the third person says that they're stressed. Now, I want you to note that we have added an event here. Instead of just having it be 2 things separated with an and, we have it being 3. It doesn't change anything in how your formula works. You can have 10, and every time you put an and, you're going to put a multiplication. Okay, so my formula is just going to expand out, and we're going to say, okay, we want the probability that the first person says that they're stressed times the probability that the second person says that they're stressed times the probability that the third person says that they're stressed. So again, we're just kind of breaking this up and putting the multiplications in between. Okay, so the next thing I'm going to call your attention to is the percentage. All right. So when they tell you that 46% of Americans are stressed at least once a week, they're giving you the probability of one person being stressed. So any one person, the probability that they experience stress is 0.46. Now, keep in mind, I can't put 46% into my problem because I can't calculate with the percentage, right? So that's why I'm changing that to a decimal. Remember, to change a percent to a decimal, you're going to move that decimal place 2 places back to the left. All right, so when I look at my first person being stressed, the probability that that first person is stressed is 0.46. And then I go to the second person and I say, okay, what's the probability that the second person is stressed? That is also 0.46. And then the probability that the third person is stressed is 0.46. And so now I'm going to multiply those three numbers together. Right, and more than likely you're going to be asked to do 2 or 3 decimal places. So I'm going to do 3 right here because the first one's a 0. So I get 0.097 when I do that on my calculator and round to 3 decimal places. Okay, so like I said, this is a really common type of problem. And I want you to kind of recognize it because it's not that difficult to work once you get the hang of it. All right, like once you realize, okay, if they're giving me a percentage and then they're asking me for a certain number of people, that really all I have to do is take that decimal and multiply it by itself, however many times we need for the number of people that we're dealing with. All right, does anybody have a question right there? Okay, so let's look then at the second one. Okay, so it says, the second one says we want the probability that none say they are suffering great stress at least once a week. So we're still dealing with 3 people. So this means that the first person says no stress for me. And the second person says no stress. And the third person says no stress. All right, so I'm going to shortcut just a little bit here. I know that these ands are going to go to multiplications. All right, so now I need to figure out how many people say that they're not stressed. So I know that 46% say that they are stressed. So do you know how to figure out how many would say that they're not stressed?
Do you subtract 46 from 100 to get the rest of the percentage?
Perfect. So 100 minus 46 is going to give me 54. And that's the percent of people who say that they're not stressed. Right, so I'm going to put 54.54 up here. And then I'm going to use that in my problem. So what is the probability the first person is not stressed? That's going to be 0.54. And the probability that the second person is not stressed, that's going to be 0.54. And the probability that the third person is not stressed, also 0.54. All right, and then I'm going to multiply that together. And I'm again going to do 3 decimal places. So it's going to be 0.157, but you do whatever Connect Math asks for. So if they want 2 decimal places or 3 or a fraction, whatever the case may be, you can do that. All right. So looking at that, does anybody have a question on that one? Okay. All right. So let's look at this one. 3 cards are selected from a deck and not replaced. So that's important to note that we're not replacing the cards, which means that when you pick the first card, you're keeping it out. And we want the probability of getting, the first one says 3 jacks. All right, so this means that we want the first card to be a jack and the second card to be a jack and the third card to be a jack. All right, so I know that those ands translate into multiplication. All right, so my formula says break it up, put the ands in between. Okay, so help me with the first card. So when I pick the first card out of that deck, what is the probability that I get a jack?
Four 52.
4 out of 52. There are 4 jacks in the deck. There are 52 cards altogether. Okay. Now remember that you are not replacing the card. So you are holding in your hand a jack. All right, you're not putting it back. You're holding it in your hand. You reach back into the deck. How many jacks are left in the card deck?
51.
Okay, there's 51 cards altogether. Good, because you've got one in your hand. And how many jacks are left in the deck?
3.
Good. All right, so now you're holding 2 jacks in your hand. You reach back into the deck. There are only 50 cards left in the deck because you have 2 in your hand. And there are only 2 jacks left in the deck because you're holding 2 in your hand. All right, does that make sense to everybody? You're not replacing those cards as you pull them out.
Okay, so we just subtracted the denominator.
Yes. Because
And how do we know that?
go ahead.
And how do we know when to do that?
If you're not replacing the card. So you're going to kind of have to think through it. Like you pick that first jack and you're not replacing it, then that means you're holding it in your hand. And then then the card deck is down to 51 and there are 3 jacks left in the deck. Okay, let's go ahead and multiply it and then we'll look at the next one and try it one more time. Okay, so 4 times 3 times 2, that's going to be 24. And then 52 times 51 times 50, 132,600. All right, and let's get that reduced. All right, so 1 out of 5525 is what I get. Okay, so let's try it again on the second part. Okay, so the same idea. This time we want an ace, and then a king, and then a queen. Okay, so first card, the ace. What's the probability that we pick an ace from the deck?
Out of 52.
Okay, 4 out of 52. There are 4 aces in the deck. There are 52 cards in the deck. All right, so 4 out of 52. Okay, now picture in your head that you are holding one card in your hand and it's an ace. Okay, so I reach back into the deck. How many cards are in the deck now?
51.
51. Okay, because I got one card in my hand. How many kings are in the deck?
4.
4. Good. All right, so now I want you to picture in your hand, you have an ace and a king. They have 2 cards. One's an ace, one's a king. So that means that there's 50 cards left in the deck because you're holding 2 of them. How many queens are in the deck? There are 4 queens in the deck, right? Because you are holding an ace and a king. So you have to kind of keep in mind how many cards are you holding out and what are those cards? All right. Does that make sense to everybody? Anybody want to ask a question there? All right, so if I go to reduce that, my calculator is not wanting to cooperate with me. So let me play around with it just a minute.
He gave me 32 over 663.
Okay.
It's 8 over
Yeah,
16,575.
I think it goes a little further than that. Yes, 8 over 16,575. So both of those are divisible by 8. Okay. All right. Any problems or anything you want to ask on those two?